Good afternoon, everybody. We hope you still got the, stamina to see through the last session. So Helmut and I mean, we kind of already were introduced. We just want to have a short talk on how to maintain quality in open source software. So basically, the first question we should ask ourselves is why quality? Like, why at all? So, first off, stuff with high quality, it simply works better. We have less fish in production. I don't know if you know the term, fish, fuckage, shit happens. It simply works faster, and you can see that by, if you take a look at the current CMS7 installations, they're just working faster, a lot faster than 6.2 installations, for example, and that's just due to a cleaner and higher quality code base. For all the agency people, over in the tech track, quality sells better. Hands down, anytime. If you sell a high quality product, people will get back to you and continue working together with you. The next thing is that it refactors easier. So if you have like fumbled code stuff, everybody, and I'm pretty sure everybody has done it before, guilty. And refactoring fumbled code is just, it's a pain. You don't want to do that. And it also feels better, right? So if you got PHP Storm open and your IDE just goes green, no errors, no typos, everything is typed in it, you develop faster, it has a better feel to it. Sleep better. Exactly. It works awesome for your sleep at night because you can simply leave the office with a good feeling, I didn't mess up today. And last but not least, it will save you one day. The day will definitely come. It's not a question when, if it will come, it's a question when that time will be, where quality code will actually save you from huge troubles. I don't know about the contract in Cambodia. In Germany, we have contracts with, every outage for an hour of a web service will be billed with something like $10,000. That's where quality code actually saves your life. Well, not necessarily your life, but at least your bank account. So, regarding quality assurance, there's a lot of stuff we always hear, and it's always the same stuff. I don't know if anyone of you knows Family Feud. So, we asked 100 people why they don't QA. So, our first result is people say we got no time, right? Next thing is people say the client already approved the project. We don't care. He said it's all right. Third most answer is that this code will never be refactored. Yeah, right. Then it's already nobody pays for that. Well, actually, people do pay for quality because they will get back to your agency on the next project. So, kind of in a way, they do pay for that. And the number one answer is, we don't need to do QA. I'm not kidding you, I've actually heard these kind of things. And the interesting thing is that QA is mostly about working together in a team to make it work. Well, because otherwise you're just tunnel visioning on your own code. You say, I don't see the problem, I know what it does, but maybe somebody else doesn't get what you wanted to do. And this is where Linus' law kicks in, which just means given enough eyeballs, basically all bugs are shallow, right? There's no problem that you can't solve with enough brains taking a look at it. So, regarding QA, you have to face a couple of challenges that you need to overcome or solve. The biggest issue definitely is maintaining discipline. Because QA only works if you do it 100% of the time. So as soon as you're working in a team and you don't QA a single change, that will just, avalanche on yourself, right? The next guy will, I don't do QA either, because the guy before me didn't need to QA himself. That just doesn't work. The next thing is how do you maintain motivation? And especially in open source, that's a tricky part. because you have people that discovered a bug in the software, and Typo 3 is incredibly complex in what it can do. So people discover a bug and argue, this fixes my problem. Yeah, but it kills off 5 different things at another place, right? So we need to kind of deny that bug fix on first sight, and then work together with people to make the bug fix, 100% viable for all use cases, especially use cases that people will most likely never use, but others might. Next thing is, it's a challenge mostly in your agencies, because you need to allocate time for that. QA, proper QA takes time, and you need to take that time. And this kind of renders the argument that we have no time void, because if you spend, personally I say, if you spend 5 hours on QA, you save 20 in bug fixing. And bug fixing in projects is normally stuff where you're working in an extreme high pressure environment, right? The customer's constantly calling. The project manager might not be too amused about the system going out. All these kind of things. And we also faced that within Typo 3, for example. So we did a bug fix release a couple of months back, and we changed something that was obvious to us. And we had, I think, 12 people taking a look at the patch set, and then we released it, and then suddenly on Twitter all hell broke loose. Because we simply didn't imagine someone having that use case with the uppercasing of fluid templates.
Oh yeah.
Good times. And also, now, this is where we also do spend more time on QAing our internal fixes. And if it's critical stuff or widespread used stuff, we kind of ask for more people to take a look at that and get more perspectives on how to work with the feature. And the next thing is you might need to adopt your workflows. I mean, basic QA is just open the website, click through it, doesn't work. That's easy, because you could just get up and get to the computer of your colleague, take a look at that. What we use, and we're going to get to that in the tools section, is we're using Garrett, which is a peer code review system, where you can take a look at the change, take a look at how the code looks like, because that's also extremely important. Is the code readable? Does everybody get what it should do without testing it, just taking a look at the code? And then you would simply apply a so-called +1, which is like a thumbs up. I took a look at the code, it looks all right. And there's the second +1, which is for does it work from a functional point of view.
It means you have to implement that. You change the workflow in that regard, that you don't allow changes to just get in because somebody thinks it's okay, but you change the workflow in a style that you say, okay, every code in our agency or in our team is only going in our repository if it's accepted by at least 2 other developers. Other developers must have a look at this change. So that's quite a big change in the workflow. So that you just can't, as the developer of a change, just can't press a button and then the change is applied. But you say, okay, I write a mail or I press a different button and then my colleagues get notified and 2 others must have a look at that. So that's behind this.
And the entire peer code review stuff from an agency perspective is you get more people who understand the project. Meaning, if you're faced with, like people get sick, it can happen. And you have immediately at least one other person who knows what's going on and can actually take over the project. He doesn't have to, that first person doesn't have to do all the coding work, but that person looked at the code, he knew what it does, and he could change that. So there are some principles which we deem like they work. So the first thing that's important also across teams is that you have an identical style of how you code. That is basically coding guidelines If you don't want to come up with your own, like we did, you can simply use something like PSR2, for example. It makes sense. It's a worldwide standard. It's the only PHP standard, if you call that a standard. So that you know that everything is indented in the right way. The method signatures look the same. You try to aim for a certain amount of parameters in the method, all these kind of things. And that's really important because suddenly you don't have to switch anymore between two totally different code styles. So you have a guy who does, I don't know, who does PHP but comes from a Java background. He will work with curly braces on new lines most of the time. And then you have like the PHP people, and they normally don't do that. But luckily, that's why you have coding guidelines, and then you use PSR2 and you put the curves on the next line.
And a small story why actually coding style matters and can avoid bugs is Heartbleed. I don't know if you have heard of this really severe SSL vulnerability, which basically compromised all servers that use that. The error in there was that the if statements weren't embraced with curly braces, but just if and then the next line, the next line was executed if this condition was true. This works in C, and this also works in PHP. If you don't use curly braces around your if, then only the next line is
Regular braces, right? Curly were missing curly braces.
Only the next line is executed, and if you write curly braces, then everything in the curly braces in this section is executed. And the error in there was that by copy-pasting, there was an if, blah blah, if this condition is met, then do this. And the do this was pasted 2 times. Right? So it was if, and then do this, and then again do this. And it was also indented, I think.
Yeah,
but the actual code which was executed was if this is true, then do this. And if this was not true, it was done as well. So because the curly braces was missing. And this error would have been much more obvious with curly braces because then
potentially not happen at all.
Or potentially it didn't happen at all. Because then you would have 2 same statements within. Yeah. So actually it helps to improve quality by just being able to better read the code. You can better read it and better understand it across teams, across people.
Absolutely. And I have to admit that I was coming from a background like, it's code. Why should code be readable? It's no book. Well, actually, it kind of is. So, understandable code and readable code actually directly results in quicker work because you don't have to fiddle through, abbreviations and stuff. So, what does $_p do here, right? And if you have something like $page object, suddenly you know what it does. It's speaking to you. Code is speaking to you. And that definitely makes a lot of sense. I think the next bullet might raise some controversy. But documentation of your code is extremely important. The thing is, if you're working across teams, it gets even more important because you need that other person to get what you were thinking in the middle of 3 a.m. on your own, recording stuff. The other person has to guess what you're doing, making QA extremely, time-consuming. So documenting not only your code, but also functionality, so stuff that happens. Say you have a public API, and your code adds a new setting that you can set from the outside. Document that in your code, what it does, and also do a documentation somewhere else, like, I don't know, like an RST file, or a wiki page, or a post-it, for God's sake. It doesn't matter as long as it's documented, ideally digitally, so that you can share it across teams. But documentation is part of quality, definitely. Next thing you should, next principle you should aim to apply is identical lingo across teams or within the team in general. So bilingual, we basically mean that you should have a common way how to name your variables, right? So no $p $T, whatever, or $K is used very often, just for key. Also define a common lingo on commit messages, because there's nothing more tedious than walking through 50 commits and having to adopt to something else all the time. If your commit messages follow a certain format, like having the ticket number in front, then a short description, what has been done. And that's also extremely important. Don't write what wasn't working. Write down what you fixed, so that you can have a change log which would simply say, now the button is green, because commit message button used to be red. Okay, what does it do now, right?
So basically, write the intent of what the changes should be. So, what should this change make better or change that way, and not what it, why it is there.
Why it's fixing it, because it was broken. That's the idea. And also, coming back to documentation, you should try to, you should define a common structure for your documentation. We can show some examples how we do it in tab 3. But all documents that we have, it's like small structured documentation. Like we did a deprecation, right? So we deprecated a certain API functionality. And these files follow all, they all have the same form, right? There's a headline, there's a description, what has been done. There's part affected installations or impact. We have impact, affected installations, and path to migrate. And if you do that constantly on all your documentation, you are able to do like automated stuff, because things that follow the same form are extremely easy to deal with for computers. And annoying, tedious tasks should be done by computers.
Yeah. Two things. I forgot to mention the commit message that is also it is extremely important that you link or have a link in your commit message to a more detailed description of what should be changed, meaning a ticket system, right? So we do this all the time, and it's really a hard requirement. No change can go into our Git repository without being linked to a ticket. That's very important, because the ticket should describe what is actually wrong, and the commit message describes how what is wrong, fixed it, and only linked together it can show you the bigger picture. And about documentation structure, which is a very general thing, what Mathias said, we especially introduced this, or some special documentation and a special structure for three things. We deprecated something, we broke something, or we changed API, and we introduced a feature. So,
and we have important stuff.
Yeah, I don't like that. But so, why did we do that, and what does it has to do with quality? So, for us, it is delivering better quality for you as agencies, because you can have a defined way where you can look what is going to break in future versions, or you can look at a certain place and then you see what feature added in a very fine-grained way, and of course deprecations, which means what should or must my developers change if they want to adopt to later versions of Type 3. So it was a commitment we made to improve the quality for your projects.
And I mean, just a small side note on stuff we're working on in the lab is there's this idea that we will actually parse those information, so deprecations and breaking stuff, and then deep code inspect your code, so that we can later on say, we have 20 breaking changes, and you're affected by 3 of them, which are this one, that one, and that one, in this, that, and that place in your code. Just news from the lab. We're working on that. That would be pretty damn awesome, because you could simply do the migration with a kind of wizard. And I mean, Christian, who's actually doing that, he's a bit, like crazy, because he tries to fix the code. So there's a button next to each file that you can just click and it will adopt the code. But we'll see if that works out. I think it's good. The next thing that that's awesome.
No.
Quite cool. So, as we said earlier, we definitely recommend peer reviewing. It makes sense to have four eyeballs on a certain change. It's tricky, especially for the project managers.
Actually, we require 6.
We do 6.
Yeah.
Yeah. Definitely we do 6. If you got 20, you do 20. 20 is fine. But it's hard on the project managers because the developer will get to the project manager and tell him, I fixed this. And the project manager is, instantly rushing to his phone, I can call the client. No, you can't. You need to do QA first. So that's also a discipline thing that you will need to deal with. You'll love it. And that moment when the developer comes to you and says, I fixed it, and introduced a regression, so we broke something else. Because that call with the client ain't nice. So just plan for the extra time. And the last thing, or the last principle, is automated tests. You get this all the time. Do unit tests, write more unit tests, write functional tests, write acceptance tests. And I mean, I guess everybody has been sitting in a plane right now. Would any one of you enter a not unit tested airplane? I probably wouldn't. So the trick is, the more you can test, the better it is. The tricky part is that tests don't really reveal their true power until you refactor your code. So at first you test what it should do, and then, right, all the tests go green. That's easy. But if you refactor things, which are in, I don't know, like an inheritance chain, like 4 levels in, it's very hard to keep track of all these things. And you change a small thing here and something breaks over there. And that's after refactoring when unit tests really reveal why they're so important. I hated them at first. Trust me, I'm with you, but they saved our asses a couple of times. And so a lot of the things we do is based on unit tests. We got 7,700 kind of unit tests right now, plus a couple of hundred. It's a lot of stuff.
Yeah, that's where the change of the process also kicks in. So that you not only require peer reviews, but you say, okay, no change goes in without unit tests or without acceptance tests or whatever. And we kind of enforce that. Yeah. It's a soft rule for our project.
Testable stuff needs to be tested. Yeah.
But we did a good learning there, because in the beginning when we said, okay, we have now automated tests, changes came in and only a few people said, please add a test to that to prove that your change is good and it doesn't break anything else. And people really came up with the things loaded on the slides, which, yeah, but I don't have time, or I don't know it, I don't know how to do it, or it's not really needed because it works for me, the fix, and stuff like that. So the excuses came up with our contributors as well. So we improved in that area, that we changed the workflow and we changed the mindset in that way that even more people just say, okay, this is a really complicated change, write a test for that, and if the new contributor doesn't know how to do it, another more experienced one very likely kicks in and says, okay, I do the tests for you, and
or help the new contributor writing the tests.
Yeah,
right?
or,
So it's
or
more
even that.
mentoring.
Exactly. And last thing I want to mention about that, it's not only about having a safety net when you refactor things, but also proving that you're doing the right thing, right? So it's not only once that a unit test revealed, okay, I write my expectation down, and I execute the test without the change, and it works. So why do I need the change actually? Or the other way around also happens very often. I write my expectation down, execute the test, and it doesn't work. Although the code looks good at the first sight. So it's really the safety net, not only that you don't break other things if you have a lot of them, but also to do the right thing in the moment you're doing it.
Yeah. Plus, in the overall scope, tests will change the way how your architecture looks.
Yeah.
So
that's yeah.
if you have like methods which have extremely ambiguous return values, so you have like a method which takes, I don't know, an array as a parameter, and it returns null or false or an object or maybe grandma's birthday. That's extremely annoying to test. And suddenly, you don't want to have this annoying testing phase, so you write a method that returns something, reliable. So the test is easier, and suddenly your code gets cleaner, because it's also a performance thing. If you have different return values, and you use that method on certain places, every method that uses the result of said method needs to re-evaluate what did I get, null, false, an array, maybe mom's birthday, I don't know, all these kind of things. And these add up, like big time. So having a clean result or a clean return value in the first place will speed up your code massively. In Germany, there's Trivago. It's like a hotel search kind of thing, and they have their price search, which is 2,000 lines of Symfony code, generating 85% of their revenue. And if you see the constructor of that method or that class, it simply takes a lucky 18 dependencies from the outside. All these kind of things. Refactoring these was simply impossible because they didn't write tests for that. So the idea is write your tests first. Your architecture will improve drastically. The safety net is there. Your code quality will get better. It's the right thing. All right. Any additions to tests? Tech guy. All right. So some stuff about the tools that we use in the Type 3 project. We use PHP unit, which hopefully most of you are familiar with. It's like a unit testing framework for PHP written by Sebastian Daphne. We use Codeception, which is currently work in progress, so we did the groundwork for that, which is like the mother of testing framework because it can run unit tests and functional tests and acceptance tests. Acceptance tests are like Selenium tests where you automate the browser. So simply write down a click path for a user in the browser, and then Selenium will pick that up and actually click that in the real browser. And if something fails, we'll get a screenshot and the HTML source spec and all these kind of things. Java, I'm not entirely sure. The server team takes care of that. But it's open source. All of these are open source, kind of. Except for the next one.
It's open source.
Oh, indeed, true.
It's a service.
Yeah. We use Travis CI, which is a Berlin-based company that runs testing infrastructure worldwide out of the cloud. And it's free for open source projects. You get like 5 parallel VMs that you can spawn up. And now comes the interesting part about tools. We use Slack as a tool. So we have a chat system in place, but we make it like, we utilize it to ensure quality throughout the entire project. And we'll show you some details on that in a minute. And the last thing that we have is Forger, which is just a custom-built app that basically I wrote together with 2 other persons that was simply help us in visualizing what the team's doing and doing a couple of cool other stuff. I said we just demo that right now, that makes sense. So first off, we got Slack, which you don't see. Give me a second. So that's basically what? I'm on the wrong one. We'll just take a look at this one. So Slack in general it's just a chat, right? So you see people just writing whatever, we got a lot of channels, and it's currently, I guess, around 1,200 people on there. So there's channels for that. There are private channels that you can go into. You can do direct messages with all the other persons that are online or offline. And the really cool thing about Slack is that it supports integrations. And integrations are stuff like this, for example. So what you can see here is all tickets that were created on our ticketing system, which is a Redmine installation, today. So these are the 3 tickets that came in today. And the interesting thing is that why do we consider that quality? Very simple. There is a group of, okay, it used to be 5 people, now it's 50. You can see that up there on top. That actually take a look at all the tickets that get opened up on the ticketing system and immediately react to these. So this means our current record is 45 seconds from a ticket that has been created to resolved. It was a user error, it was easy, but still 45 seconds to close down the ticket on an open source project. Cool. The next thing that we have is that Frank actually came up with a bot. So what you can see here, that's our Shadow 3 bot, and you can trigger it by using certain keywords. So what you can see here, maybe I can zoom. That's better. So then you go simply type review, show, and then the number of the review on Garrett. And we'll just show it together with the link. The trick is it's incredibly easy to share links with these without losing sight. Imagine that while we're code sprinting, we have 40 to 50 people in 2 different locations working in one chat channel and discussing things. So it's incredibly easy to just use these review tools here. Also, whenever a completely new review will be created on Garrett, the bot will tell us. And also if we merge, right? So we'll see something. Here you can see Travis going green again, which meant there used to be an error in the testing, which made it to live, and then it was fixed. Give me a second where we got this. Yeah, the team seems to be quite active today. There we got a merge. So what you can see here with the green thumbs up icon, this is simply a patch that got merged earlier today, and you can just click on it, and you're immediately going to the Garrett code review. And now let's go. Garrett code review. Okay. So this is basically what a change looks like. So what you can see is maybe I should go to there. So what you can see here is that we have the owner of the change, which is Georg Ringer, and you can immediately see what we did with the commit message up on the left. So we have we can immediately tell this is a follow-up. So something that needed to be done following another ticket immediately. The next thing that you can see, we have this task keyword. So we define tasks, features, bug fix, cleanup, documentation. Yeah, right. Anyways, we try to keep it low. And this is also something about, we mentioned lingo earlier. We used to have the tag bug. Actually, it's a bug fix, right? You don't want to introduce new bugs and then commit them. And we can also see here that we have this short description. What's this issue about? I combined several calls to allows table on standard pages, and then the function accepts a comma, separate the string to add multiple tables. So this is what it will do now. obviously it used to be broken. So we have this results line right here, which takes a ticket number from our ticketing system. So I don't know what you folks use. Some use Jira, some use Redmine or Mantis. I've seen them in the wild too. You can just combine all these things together in Garrett. The next line we can see that this change currently only targets the master branch. And there are tickets that also target like a 6.2 branch, then you will find one. Well, yeah, we'll take a look later. So what you can see down here was or what you could see before was the changed files. So this is just a standard diff, and I have to admit it doesn't work on narrow screens. If the Garrett stuff doesn't fit on your screen, ask your manager for a bigger one. So it's just a separate diff that you can just take a look, and it's like magically scrolling in both directions at the same time. So now you can simply see what has been changed, and that's the code reviewing part, right? You take a look at the code, what it does. You don't test its functionality, you just take a look if it makes sense. And you'd be surprised how often code does not make sense just by looking at it. And then you get to the contributor and ask him, dude, what's this? He's like, I have no clue what I was thinking. I'll fix that. And we hope to get the newer version of Garrett soon, where you can actually change the code in here directly. So simply log into Garrett, click on a certain code line, and then edit the code as you go. Right now you need to re-upload another patch set. And unfortunately, we only have one patch set right here, but we can see the history of the record of the patch down here. So here I uploaded patch set number 1, then Wouter gave it the +1+1, which meant I took a look at the code, it looks all right, and it works. These are the 2 +1s. Then we have Jan, who actually just did a code review because maybe he isn't able to test it right now. And then we had Georg Ringer +2+2ing it, which is like a special thing that a core team member can do because you're not allowed to merge patches regardless of how many +1s you have. You need at least one core team member to approve this finally. And the reason for that is that if you +2 it and you merge it, you immediately take responsibility for this patch. So if this patch breaks, you fix it. So that's why, not have everybody like do it. And then there's some other statistical information like how many, you can see the +2s and +1s right here as well. You can see how many files, how big the change set is, times, and all these kind of things. And you actually do post-merge reviews too.
Yeah, so one last thing about the interface here. Once we merge, Garrett does something really nice for us, which is amending the commit message and putting the link to this change in here in the commit message, which means if you stumble over some change in the core and think, okay, why was this changed at all?
Who did this?
Who did this, for example? And what was actually changed? And what's the link to the ticket or whatever? Then you can look at the commit message and just follow this link, and then you end up hopefully again at the exact same place.
It links to itself, yeah.
In this case, it links to itself. But if you're using your IDE or whatever and see the commit message there, or your Git UI or whatever, then you hope your browser go in here.
Which is documentation.
Which is kind of documentation what we've done. It's kind of a great changelog. And if you go back here, why is this integration with the merge stuff? Why is it quality assurance? It is because some people in the team recognize that something is merged. That's not obvious. So I'm not every time looking at all Git commits, but if I'm in the core dev channel and I see such integration, which is really very visible popping up, then I see, okay, I read the commit message, which hopefully describes very good what it is, and then I say, okay, this seems obvious even from the commit message, it's okay. But very often I look at the commit message and say, okay, this doesn't make sense from my perspective or from my experience. I'm going to have a look at it. Or this sounds very complicated, or this sounds like high impact. And it's hard to tell when I'm going to do it. It's very something like experience. I'm not able to look at everything, or not everybody is being able to look at everything. But it's really helpful to doing post reviews for certain things, and I only can do that because I see that here.
Yeah. Or you would need to constantly reload your UI. Right?
Yeah, constantly.
That's stupid. Exactly. Pushing stuff is better.
Yeah. And how many minutes do we have left?
Like 5.
All right. Yeah. So maybe one last thing about the Travis failure. Was just scroll up a little bit. So yeah, there it is.
Here we are.
So Travis is our we said quality or tool is or principle is having automated tests, and Travis is our automated test runner. Basically, it's a service and it's connected to GitHub directly, and we have our repository also linked to GitHub. And this tool just executes our tests. And if these tests, or some of these tests fail, we get immediately a notification here. And since every core developer is in this channel, we can act immediately. So it's very, it doesn't happen that which happened before, that we release something, and after the release we recognize, oh, okay, there was
What's Travis for?
Yeah,
but nobody knew.
Because we now see it. Just that you have a quick impression how it looks like. Hopefully it loads. Yes, it works. So this is the Travis CI UI, which is very convenient for us because we have only one file. It's called .travis.ynl. It's a YAML file, and in this file you basically configure what you want to test in which environments. And here you see that we are going to execute all our tests on PHP 5.5, PHP 5.6, and even PHP 7, although it's not released yet. So we prove that our code, or at least the code that is tested in this way, works in these environments. So yeah, that's basically our tool set.
How would I hope that Helmut committed Travis code?
Yeah, actually,
yeah, it was not his fault.
Actually, no, because there was another commit that broke it.
Exactly. So the last thing I wanted the last thing I wanted to show from the tool set is like it's Forger, which is, you know, if you get to this, you have this nice like marketing kind of vibe dashboard. And we'll just like group together a load of data. But the important thing is that what this actually does, it motivates people from the team, because suddenly the team is able to see what they do. So we had that in the opening talk. This is, for example, so what you can see here, these are the green ones are the closed tickets, and the red ones are the green tickets. So as long as you can see the light green, everything's good, because it's not more tickets being opened than we're closing. Then you have some. I think this was a code sprint. And the good thing is that suddenly the team goes like, yeah, we have more open tickets than closed tickets today. You know, it's like 1 hour left. Let's do this. You know, we simply get the ticket count down. Then it's just stuff like how many open tickets we have in a certain tracker and how high is the cycle time between tickets. Open tickets over time, which is basically the velocity chart flipped upside down. Open reviews over time, and the Garrett review and loading. Damn it. I crashes. Will it load? No, obviously will not. But this is just visualization of what's actually being done in the project, and this will greatly increase the throughput and the result of the team, because this is pure motivation. And apart from these things, we also have like weird. We have like a couple of what's happening. Please close your devices, everyone. I want to demonstrate something. So I just walked you through the process. We got a lot of menu bars, menu items in the bar, and my time's up. Sorry. It's cool. We can show you in detail on the next conference. Thanks a lot.